Okay, this is the P3 paper from October 2021. It's question number 10, which is the last question in the paper. It's some work on trig addition formulae, the double angle formulae. We're going to be proving a trig identity here, and then we're going to be trying to work out this area here by integrating some trig formulae as well. So let's make a start and get going with it. 7 marks for this one, quite a lot of work involved in it though. So part A says this is the curve, but we don't need to worry about that too much. It just says, can we prove that identity and work out what P, Q and R are going to be? Yeah, absolutely. We can get started with having a look at that. So part A, we've got 1 plus 2 cos 2x squared is going to be identical to, what did we have, P plus Q cos 2x plus R cos 4x. Okay, so I'm just going to take the left-hand side and in effect I'm going to multiply out that bracket. So 1 plus 2 cos 2x squared. If you want to take your time and write it all out next to each other and do it, I know what that is. That's going to be 1 plus 2 lots of 2 cos 2x. So that's 4 cos 2x. And then it's going to be 2 cos 2x all squared. Well, that's 4 cos squared 2x. So I don't mind if you take a little bit longer to get to that stage. That's absolutely fine. But then what we're going to do is we're going to use the identity cos 2a. There's 3 of them. There's cos squared a minus sine squared a. There's 1 minus 2 sine squared a. Or there's 2 cos squared a minus 1. And hopefully, obviously, we're going to be using that one in this work to tidy up the answer. So although we had the choice of them, it's this one we're going to use. If that's true, then cos 4x is going to be the same as 2 cos squared 2x minus 1. That should absolutely make sense to you. So cos 4x plus 1 is equal to 2 cos squared 2x, and you can see what I'm trying to do. I'm trying to get to the stage where I've got 4 cos squared 2x, so 4 cos squared 2x is just 2 lots of cos 4x plus 1. So I can now make that substitution in there, and I'm going to get that 1 plus 2 cos 2x all squared then actually worked out to be 1 plus the 4 cos 2x plus 2 lots of cos 4x plus 1, which all tidies up to 3 4 cos 2x and 2 cos 4x. So if we compare that to what we had up there, we've now managed to work out our P, Q and R. Okay, let's go back and have a look at the second part then. So the second part says what we want to do is we want to work out this area here, but the key is to find out what A actually is, because this is where the curve is going to equal 0. The curve equals 0 here, it equals 0 here, equals 0 here, equals 0 here. And what we want is the second time that it equals 0 on the positive x-axis. So let's just go away and actually solve it, and then we'll explain where we're getting the second value from. So again, we need to just explain it to the examiner first of all. So by B, we need to find limit A, which is going to be y equals 0, which is going to be 1 plus 2 cos 2x squared equals naught, which is 1 plus 2 cos x, sorry, 2 cos 2x equals naught, which means 2 cos 2x equals minus 1, cos 2x equals minus a half. So we're now trying to solve that. So if we do try and solve that, just a quick reminder about the cos diagram, all sine, tan, cos. When is cos going to be negative? For these values here, we get, if cos x equals a half, means that that's pi over 3 there. So we get pi over 3, pi over 3, pi over 3, and pi over 3. This is the way that I do this cos diagram. And I want the two possibilities when cos is negative. So it's either that value there or that value there. Well, what are those two? That angle there then, in black, this angle here, one of my answers is 2 pi over 3, and the other one of my answers is 4 pi over 3. Okay, let's just do that then. So I get that 2x is equal to 2 pi over 3 or 4 pi over 3. Well, that's 2x. I don't want 2x, I want x. So my possibilities for x now are pi over 3 or 2 pi over 3. So if we go back to our diagram then, that value there is pi over 3, but we want this value here, a, as being 2 pi over 3. So I can say a is equal to 2 pi over 3. And then what do I want now? If I want this area here, it's simply the area under the curve from 0 to a. So it's the integral of y dx. Let's just say that then. So area needed equals the integral from 0 to 2 pi over 3 of y dx. So what did we have there? We had the integral from 0 to 2 pi over 3 of 1 plus 2 cos 2x all squared dx. And then we already know now, let's give myself a little bit more space for this, that that's the integral between 2 pi over 3 and 0 of 3 plus 4 cos 2x plus 2 cos 4x. All between 0 and 2 pi over 3. Okay, so just some integration of trig functions then. It's going to be 3x here. If you have troubles with integrating trig functions, go back and look at another one of my videos here. I'm going to do them quite quickly. The integral of cos is sine, so it's sine 2x. Hang on a second, let's just move that over a bit. The integral of cos would be sine, but because of the 2x, we have a half, and we've got the 4 there, so it makes that. Same idea with the cos 4x, the integral is sine, but because of the 2 and the 4, we're going to get those ones, all between 2 pi over 3 and 0. Let's tidy that up. So we've actually got 3x plus 2 sine 2x plus a half sine 4x, all between 2 pi over 3 and 0 now. So putting that in is 3 lots of 2 pi over 3. It's 2 sine 4 pi over 3 plus a half sine 8 pi over 3. Just be careful with all of these values. Okay, minus, and the other one is going to be, so if I just put that in square bracket, let's just move all of this over a little bit, just give myself a little bit more space here, minus, Here we're going to have 0 plus 2 lots of sine 0 plus a half sine 0. And then obviously sine 0 is 0. So all of this second bracket disappears. But do just check it just in case. Chug everything into that and tidy it all up. And it comes to 2 pi minus 3/4 of root 3. I'm pretty sure it will say exact answer, will it? Exact total area, writing your answer in its simplest form. So, yeah, a good question to finish off with there, and hopefully that all makes sense to you.